All right, friends and neighbors, welcome back to another networking video. This one, we're going to sort of try to wrap our arms around what IP addresses and the Internet Protocol are really all about. So, the title of this one is, I heard about this thing called an IP address. Now, maybe the very first instructive thing that we could do is realize that an IP address, or an IPv4 address, is actually an Internet Protocol address. And the minute we say that it's actually a protocol address, we realize that we're actually talking about, well, a protocol. And so we have to realize there's a lot more going on. So let's go over a couple of them. Certainly, we have the IP addresses themselves. Now we're going to talk just a little bit about all the different kinds of IP addresses. And maybe I should also, at the outset here, say, look, in the show notes of this one, I'm going to have lots and lots of links to some RFCs and other videos because I just wanted to give us sort of a jumping off point and to realize that if you're trying to learn something about networking, you're trying to get started, and we start with an IP address, well, what does that really mean? What's the whole thing? And what's maybe the rest of the story or the chapters in the rest of the story? So even with an IP address, there's a lot of different stuff that we could learn just about IP addresses themselves. But like the protocol, we have to realize there's a lot more going on than just getting a single IP address. Now, to get us started with some of the ideas or some of the topics, we'll go to the document that sort of started the whole thing, or at least one of the documents that started the whole thing, and that is RFC 791, entitled The Internet Protocol, and it dates all the way back to 1981, so nearly 25 years ago. Now, in there, you'll certainly find stuff about IP addresses, but there's also the operation of the protocol itself, the header format, how is it structured, and we'll see that it's made up of lots and lots of fields. We've got quality of service, or what we call it at the time, type of service, fragmentation, and then, of course, all of the addressing stuff. And if that wasn't enough, it turns out that you can do stuff with IP addresses or the Internet Protocol with options. So you can do a wide variety of things to expand the header and provide some additional functionality. And I'll put the link right here, but I'll also include it in the show notes so it's actually clickable. And here is an IP packet. Everything that you want to do on the internet today takes data and it sticks it inside an IP packet. So it doesn't matter if you're pinging something, if you're browsing to something, if you're doing email, if you're doing games, if it's going across a network, it's going to be in an IP packet. Now, maybe it might be an IPv6 packet, but still today, almost, well, the vast majority of traffic is still going to be in IPv4 packets. So if we take a look at this whole thing, that's the header, right? And it starts way up here and goes all the way down to here just before the transmission control protocol. We can see that there's lots of information there. In fact, there's 20 bytes of information, and only 8 of it is going to be the source and destination IP address. So you get an IP address, whoever you're talking to gets an IP address, but there's a whole other fields that sort of indicate there's something else going on. So we'll just hit some high points of some of the addressing. In the early days, we had classes of address. So classes of address came from A, B, and C. But there was also D and E. E was experimental, makes sense. And D was for multicast. So there's a whole other RFC that goes to address mappings. Now, if you read through other documentation, 1122, 791, you'll see all of these references to these types of addresses, but 796 sort of lays it all out. On top of the classes of addresses, and today we do classless, so we don't pay as much attention to a rigid class structure, we also have the public and private addresses. Public addresses are things that anybody can see. So you get a public IP address, and anybody can reach out and touch that IP address. And then, of course, we have private addresses. And the minute we're talking about private addresses, like the 10net, the 172, the 192.168, we need another RFC. So RFC 1918. So sometimes you'll hear private addresses referred to as 1918 addresses. And along with that, we get something called an IP network address translator, or a translator. and that's in yet another RFC. Now on top of all of this, we've got all of these special use addresses that we need to operate on a particular network. So we've got broadcast addressing, we've got addressing for this particular host, we've got loopback addressing, so there's some examples there, and there's some other RFCs that cover these special addresses. And last highlight, certainly not the end of the story, but we have 0 or auto config addresses that begin with 169. So we very commonly start learning about the Internet Protocol, IPv4 or IPv6, by taking a look at the addresses. But of course, there's a lot of operational ideas wrapped up in the Internet Protocol as well. At the sort of top of the heap is, why do we have IP addresses, and what do we use them for, and how are they used? And that's all about getting from one network to another network, maybe across an internet or the internet. So for that, we need routers, we need routing, we need routing tables, and we're all trying to get traffic to flow between networks. And that's how we're able to talk to somebody on the other side of the globe. And then if we add to that other kinds of devices like switches and access points and gateways and all of that kind of stuff, then we start to develop a deeper and richer understanding of how networking operates. Now what if you wanted your traffic to be protected in some way, or to have priority service, or you were looking at a particular kind of traffic and you said, well, that doesn't need high bandwidth. It's okay if it gets through eventually. Well, for those kinds of traffic, those kinds of situations, we want a type of service or a class of service or a quality of service. These are the TOS, COS, and QoS bits that we set to let routers know there's something that we want to do with this particular traffic. There's some handling that's involved here. So RFC 791 talks about these precedence, delay, throughput, and reliability bits. But that's all been deprecated, so we have a whole other RFC that describes what's called differentiated services. So that same packet I showed you earlier, I just got rid of the IP addresses from it, and now I'm showing you the differentiated services field. That's this right here, right? And with these bits set, that means that we've got something important that we want to do, or we want to realize that that there's something special about this traffic. We flag it, and then the router can have a policy that changes the forwarding or behavior of the traffic. It would also be great to know what in the world this IP packet is carrying. In this particular case, this was a TCP packet, right? So by identifying this as a TCP packet, what happens is the next layer in our stack is able to decode that because it already knows the structure of a TCP header. And then, of course, we've got things like time to live. Time to live describes how many hops or how many routers you can pass through before traffic is pulled from the network. And in this way, we can protect ourselves from loops or continuously circulating packets. And then, of course, there's the options, but there aren't any options in this particular one. But options are a way to provide additional functionality to the Internet Protocol. Now, if you take a look at the packet that's at the bottom of the screen, this is a different one than the previous one because I wanted to show that some packets are just too large to go over the network. Now, that doesn't mean that we don't send them over the network. What we have to have is a mechanism to chop up the packet, send it across the network, and then at the other side, we need to have a way to put it all back together. And so we break them up at the source and reassemble them at the destination. And there are 3 fields that we use to do this. One is the flags field. It says, are there more fragments? Did we fragment this at all? And this is an indication that there's more to follow or there is no more. This is the end of the story. The fragment offset describes how far in the line of packets a particular chunk of data is going to be found. And in that way, we can put them in order. And lastly is the packet ID. All the packets with the same packet ID are the ones that are going to go back together. So collect all the packets with the same packet ID, figure out the offsets, glue them back together, and there you have the original packet or datagram back. Now the other thing that's notable here is the total length is 1500. If you are sitting on an Ethernet network, 1500 is the maximum data size that you can send across the network. And so anything larger than that would have to be fragmented. Well, this has been our jumping off point to the Internet Protocol. And now we know that when we get an IP address, it's much more than just an IP address. There's a lot going on, and there was a lot that happened to get that packet from source to destination. I'll put lots of links to the RFCs and videos in the show notes. And thanks for watching, thanks for listening. Like and subscribe if I helped, and may those IPv4 packets always reach their destinations.